Hello, in this video I'm going to solve the following problem for you. Evaluate the following integral. Integral of x times the square root of 2 minus x squared all over the square root of x squared plus 1 dx. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, one possible answer that you might get is as follows. 3/2 times sine inverse of the square root of x squared plus 1 over 3 plus 1/2 square root of x squared plus 1 times 2 minus x squared plus a constant c. Okay, so let us solve the problem together here. The first thing that I will do, because I see that I have x dx here, so it motivates me to get rid of one of these square root signs by introducing a new variable, say u. So I would say that, let us say u is equal to square root of x squared plus 1. Then I raise both sides to power 2, so u squared becomes x squared plus 1. Then I differentiate side by side. This becomes 2u du, and that one becomes 2x dx. And of course, because I need x dx, I divide both sides by 2, and I have my combination here. Yes? Okay, but if I introduce a new variable, I have to get rid of my old variable everywhere. Okay, so I don't have any problems here. I can replace u here. I don't have any problems there. So I also need to write 2 minus x squared in terms of my new variable u. Okay, that's also easy because I can immediately see from here that x squared is u squared minus 1. But this means that 2 minus x squared that I need is 2 minus u squared minus 1. When multiply minus sign in, it becomes 3 minus u squared. And that is my 2 minus x squared. So that's also something that I will need. Okay, so this integral that I call this I now can be written in this form. Integral, in the denominator, I just simply put u. Instead of x dx, I write u du from this relation. And then I have right square root of 2 minus x squared, but 2 minus x squared in terms of my new variable is 3 minus u squared. And then you immediately see that this u and that u are cancelled. So what is happening is just a very simple standard integral that we use trigonometric substitution to solve. And this is a very famous one. So if I want to introduce the trigonometric substitution, that should be like this. So I will introduce the variable theta to be sine inverse of the square root of this variable u divided by square root of this number, square root of 3. The reason that I introduced it in that way, because if I introduce it in that way, it not only introduces a new variable, but also tells me that this variable theta should lie somewhere from minus pi over 2 to pi over 2, because theta is within the range of a sine inverse function. This will be helpful in a moment, you will see. And then from here, of course, I can conclude that sine of theta is u over square root of 3, or u is square root of 3 sine theta. But what I need here is du. So it motivates me to calculate du as well, which becomes the square root of 3 times cosine theta d theta. Okay, so I put them here, and then I solve this integral, the new integral. So the answer is I equals to integral. I would write it here as square root of 3 minus, instead of u, I write this expression, I square it, so it becomes 3 sine theta squared. And instead of du, I just simply write square root of 3 cosine theta d theta. And then, of course, I can factor the 3 out here. Okay, but then square root of 3 coming from here and a square root of 3 coming from there, it gives me a factor of 3. I pull it out, integral, but 1 minus sine theta squared is cosine theta squared, and then I have a square root of cosine theta squared, which becomes absolute value of cosine theta, and then multiplied by another cosine theta d theta. And this is where I, in principle, need this, because theta is in the fourth or in the first quadrant, it means that cosine theta is positive or not negative. So in principle, I don't need the absolute value sign. I can remove it because it is not negative, and then I will have cosine, which gives me cosine theta squared. And of course, I have a 3 there, so it becomes cosine theta squared d theta. And that is extremely standard problem. It's an extremely simple problem because it's a very standard integral. So you have to use the double angle formula, which is this one for cosine. Okay, so I put this here, this 2 goes out, so it becomes 3/2. And then I have integral of cosine 1 plus cosine 2 theta d theta, and I integrate this. The integral of the first one is just simply theta. The variable of integration is theta, and this one becomes plus 1/2 sine 2 theta. And of course, it's a good point to introduce the constant of integration here. Okay, now of course this integral is finished, but I have to go back to my original variable. So I have to switch from theta to u and then from u to x. So I have to do it in 2 steps. In order to do that, I want to use the formula for sine 2 theta here as well, because what I know about sine 2 theta, what I know is about sine theta, okay? So that's a good thing to use this formula. And then what happens? This 1/2 that you see here will cancel that 2. So if I continue, it becomes 3/2. And then I will have theta plus sine theta cosine theta plus a constant c. And now I switch from theta to u. Yes? So what we need to do now, I continue here. So this becomes equal to 3/2. So instead of theta, I can use this. So it becomes sine inverse of u over square root of 3, and then plus, instead of sine theta, again, I can use this. Yeah, so it becomes u over square root of 3, and then multiplied by cosine theta. Okay, but you know that cosine theta is the square root of 1 minus sine theta squared. So you see here, let me write it here. So cosine theta is equal to square root of 1 minus sine theta squared. And I know that sine theta is this expression, so I put it here. So this becomes multiplied by square root of 1 minus, this expression is squared, it becomes u squared over 3, and then I have my constant c. Okay, so let me do some simplifications here. So 3/2 sine inverse of u over square root of 3. I factor 1/3 out. So it gives me 1 over square root of 3, and then a square root of 3 minus u squared plus a constant c. So let us double check. So I copied and pasted this one. I multiply this back in. This 3 and that 3 will give me 1, and then this 3 will go in the denominator, so everything is in order. And then of course you see that this one and that one becomes a 3, and then I multiply this factor in, so it becomes 3/2 sine inverse of u over square root of 3, and then this is a 3, which will be cancelled by that 3, so I will be left with 1 factor of 1/2, and then I will have u here, square root of 3 minus u squared plus a constant c. Okay, one more step, and by the way, I don't need this anymore. Now I have to switch from u to x, and then of course that's also easy because you see u is on the board, so I have just to put it here. So what happens? It becomes equal to 3 over 2 sine inverse of square root of x squared plus 1 over 3. Yes? And then I have plus 1/2. U is again square root of x squared plus 1. And then I have square root of 3 minus u squared is also on the board because 3 minus u squared is 2 minus x squared. And then I have a constant c. Of course, I can combine these two square roots. Why? Because if this problem is supposed to make sense, 2 minus x squared should be non-negative. So here x squared plus 1 is positive, 2 minus x squared is non-negative. I multiply them so I can combine them into one square root sign, and then I am done. So this becomes equal to 3/2 sine inverse of square root of x squared plus 1 over 3. I don't need that. And then plus 1/2 square root of x squared plus 1 times 2 minus x squared, and finally a constant c. And that is the answer that we are supposed to get. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.